Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a theory paper, and we have selected a paper 2. And this paper 2 is the latest paper right now, and it's November 2023. 2-1 paper. This paper 2 belongs from the zone 1. The time allowed for this paper is 1 hour 45 minutes. In this video, I'm going to present to you the solution of this paper to the best of my knowledge and my ability. So let's start today's paper. So here we go. So here in front of you is the paper. The total marks for this paper are 80. The time allowed is 1 hour 45 minutes. So question number 1, he says the figure 1.1 shows a toy water rocket. So here you have a rocket, here we have a rubber tubing. This is connected to an air pump. If I will pump this air pump, the air will be injected into this. This rocket is filled with water, so that air through these bubbles will come here. The rocket is half filled with water and connected by rubber tubing to a pump. A part is air is then pumped into the rocket so that the pressure of the air inside the rocket increases. Explain, the first part is explain in terms of the particles why the air in the rocket exerts a pressure on the walls of the rocket. You see, the air here, its particles are moving randomly. So these particles during their random motion collide with the walls, the inner walls of that rocket. So when they collide with the inner wall of the rocket, during that collision with the wall, they exert force on the wall. So that force per unit area, the force exerted on that unit area is causing the pressure. So I have written this answer as well, and let me read this answer to you. I have tried to write the answer. You can obviously write a better answer. Air particles in the rocket are in random motion. During their random motion, they collide with the inner walls of container. These particles exert force on the wall of container during these collisions. Force exerted per unit area of the wall is the pressure of the air on the wall of the container in the rocket. So you can see also the marking scheme of the first part. This question was of the 3 marks. I have already checked this answer to, I think it's right. Okay, so we are going to the next question. That is question number 1A, and its second part. It says the temperature of the air in the rocket remains constant as air is pumped into the rocket. Explain why increasing the number of the air particles in the rocket increases the pressure of the air in the rockets. You see, when the number of the air particles will be more in the rocket, the number of particles colliding per unit area of the wall per unit time will increase. So due to this, what will happen? The force exerted on the unit area of the wall will increase. So that's why the pressure will increase. Okay, I have tried to write this answer. Question number 1A, second part. Number of air particles per unit volume increases. The collision frequency of the air particles with the wall increases. More number of air particles collide per unit area per unit time. So force exerted per unit area increases. That's why the pressure will increase. So let's see. More collisions per unit time. That is their marking scheme is saying. I hope you understand this answer. Let's go to the next part. Question number 1, it's B part. When the air pressure in the rocket is high, the rubber tubing is removed from the rocket. The water in the rocket is expelled downward. Explain in terms of momentum why the rocket begins to accelerate upwards. Okay, so try to understand this with the perspective of the momentum. You see, when the tubing is intact, so the water, the rocket, everything is stationary. So the velocity of the rocket and the water both is 0. So the initial momentum of this rocket and the water is 0. So when this tubing is removed, the water starts moving downward. So the water will have a downward momentum. To make the total momentum of this system zero, the rocket will move in the upward direction. Because when the rocket will move in the upward direction, its momentum will be in the upward direction. So the sum of the momentum of the upward moving rocket and the downward moving water, that momentum will be zero, and the law of the conservation of the momentum will be obeyed. According to that, the total momentum of this system before the rubber tubing is removed is zero, and the total momentum of the system after the rubber tubing is removed should be zero. So let me show you my written answer, and then we will see what the marking scheme says. Question number one is B part and its answer. Initially, the total momentum is zero. Before the rubber tubing is removed, the initial momentum is zero. When the tubing is removed, water moves downwards. So its momentum is downward. Rocket moves upward. Rocket has a momentum in the upward direction. This makes sure that the sum of the momentum is still zero, and the law of conservation of the momentum is obeyed. So you can see question number one, B part, and here in this way, the momentum is conserved. So I hope you understand. If you need more time with the marking scheme, you can pause the video here and you can look at the marking scheme for a longer time. Okay, so question number one, and its C part is a 2 marks question. He says, as the water is expelled from the rocket, the upward acceleration of the rocket changes. Suggests two reasons for the change in the acceleration of the rocket. You see, as the rocket will start moving, so because its speed will be changing, so when the speed changes, the air resistance acting on the rocket, that changes. So due to that, the acceleration of the rocket will change. Another reason is that the mass of the rocket is also changing, because you see the rate of the expulsion of the water from the rocket as the time passes by changes. That's why the mass of the rocket is also changing. That's why the acceleration in the rocket is also changing. These are my point. This is my point of view. Question number one, C, first part. As the speed of the rocket changes, the air resistance acting on the rocket also changes. Mass of rocket changes due to expulsion of the water rate changes. You can write this. The order of this sentence is not that good. Actually, I should have written that mass of the rocket changes due to the rate of the expulsion of the water from the rocket is changes. So question number one, C part, the marking scheme is showing up on your screen. And you can look at this marking scheme. You can pause the video, take your time with this marking scheme. I'm talking about this part. This is my answer. Okay, so we are going to the next question. The next question is question number two. A lorry, which is truck, is at rest on a straight horizontal road. A constant driving force of 5.4 x per 4 Newton acts on the lorry and it accelerates forwards. A part is define what is meant by acceleration. So he's asking you to define acceleration. Acceleration is the change in the velocity divided by the time taken for that change. Or you, in other words, you say the rate of change of velocity. That is called acceleration. So here you can see acceleration is the rate of the change of the velocity. Question number two on the marking scheme is showing up on your screen. So this is my answer. Question number two, B part. As the lorry moves forwards, work is done on it by the driving force. State the equation that defines work done. Refer to the direction of the force exerted. You know, the work done is you say it is the product of the force and the distance moved in the direction of the force. We say work done is equals to force multiplied distance, but that distance is that distance is a special distance. Distance is that distance which is moved in the direction of the force. So product of the force and the distance moved in the direction of the force, work done is equal to force multiplied distance. This is my answer. So This is the marking scheme. You can pause the video. This is my answer. Okay, so let's go. Question number one, it's B, it's third part. Second, question number two, sorry, it's B, it's second part. Calculate the work done on the lorry by the driving force when the lorry travels a distance of 280 meter. You see, if you want to calculate the work done, and the important thing is that I should know the the distance moved, which is 280 meter, and I should know the force, which was exactly that is 5.4 expo 4 Newton. So if I know the force and the distance moved in the direction of the force, we can calculate the work done. The work done is equal to the force multiply the distance moved in the direction of the force. And it's a very simple calculation. So 5.4 expo 4 Newton multiplied 280 meter. So the work done will be equals to 1 point. Let me, I by mistake I wrote here. Oh, this is joule. This is not, by mistake I wrote here. This is joule. Okay. So it will be 1.5 expo 7 joule. 1.5 expo 7 joule. I hope you understand. This is the solution. Okay, at one point on the road, the kinetic energy of the lorry is 3.2. So this is the kinetic energy 3.2 expo 6 joules, and its speed is 12 meter per second. Calculate the mass. You know the formula for the kinetic energy is 1 by 2 mv square, half mv square. If you know the kinetic energy, you know the velocity or speed, we can find the mass. A simple calculation. So on your screen, the solution is showing up. Kinetic energy is equal to 1 by 2 mv square. Kinetic energy is 3.2 expo 6 joules equals to 1 by 2 m, and the velocity is 12 and square on it. So the m, when you make that m, that's the subject of the formula. Or in other words, you can say when you make m alone on one side of the equation, so you will have 3 multiply 3.2 expo 6 divided by 144. 12 square is 144. So you will get 4.4 expo 4 kg. 4.4 expo 4 kg. So my answer is right. This is the solution. This is the marking scheme showing up. This is my solution. Okay, I hope you understand. Question number 3. When the temperature of a liquid increases, the kinetic energy of its particles increases and the liquid expands. Explain by referring to the particles why a liquid expands when heated. You see, when you provide heat to liquid, the temperature of that liquid increases. That means the kinetic energy of that liquid has increased. That means that particles of that liquid have started moving faster. When they start moving faster, they hit each other with more force. So they push each other away from away. So what happens? The distance between the distance between the particles increases, and the effect of the intermolecular forces or the attractive forces is less on the faster moving particles. That's why that liquid will expand. So let me show you my answer. When temperature increases, the kinetic energy of the particles of the liquid increases. Particles move away from each other. Force of attraction becomes less effective on faster moving liquid particles. This is my answer. Question number 3A part, the answer of 2 marks is written here. If you want to read this marking scheme, you can pause the video. Okay, so this is my answer, and here we go. Question number 3, and it's B part. The heater in a kettle is near to the base of the kettle. The kettle is filled with water at a temperature of 17 degrees centigrade and the heater is switched on. State the name of the method of thermal energy transfer that causes energy to be transferred to the water that is touching the heater. You see, through the kettle, the bottom of the kettle, because the bottom of the kettle is solid, and you see, we have heater, then you have the bottom of the kettle, the inner bottom of the kettle, and then you have water in the kettle. So how the from heater to the kettle to the water the heat will reach through that base, and that base is solid and made of metal. So what happens? The heat is transferred through that solid by the conduction. So here I will write conduction. Then question number 3b, second part, he says explain how thermal energy is transferred through all of the water in the kettle. You see the water is in the kettle. At the bottom you have the heater. So the water which is at the bottom near the heater, that absorbs the thermal energy and its particles move away from each other. The kinetic energy of those particles increases, that water becomes hot because those particles of the water have moved away from each other. That water becomes less dense. This less dense and hot water rises upward. So the water in the kettle, which is at the top, is colder. It has high. It's denser, so that denser and colder water sinks downward. So this creates convection currents in the water. So by those convection currents, the heat is transferred throughout the water. And let me show you my written answer: conduction. And the question number 3b, second part. Water at the bottom of kettle near the heater absorbs heat. Water particles move away from each other. Water becomes hot and less dense. This hot and less dense water rises upwards. Cold and dense water from top sinks. This creates convection currents in water. By convection currents, heat is transferred throughout water. I hope you understand. So conduction, and this is the question number 3b, second part. The marking scheme is showing up. You can pause the video if you want to read it. Okay, this is my answer. Then question number 3b, third part. He says state the boiling temperature of the water at standard atmospheric pressure. Include the unit in your answer. The boiling point of the water is 100 degrees centigrade. 100 degree centigrade, or you can say 373 Kelvin also. Okay, in degree centigrade is 100 degrees centigrade. Okay, the question number 3 and is B and its fourth part. The kettle contains 2.5 kg of the water. So the mass of the water is given. At standard atmospheric pressure, the specific heat capacity of the water is given. You see, this is 4200 joules per kg per degree centigrade. And the specific heat, small c, is given here. When the water reaches its boiling temperature, the kettle switches off. Calculate the increase in the internal energy of the water. So its boiling temperature. Boiling temperature is 100 degrees centigrade. The initial temperature of the water is 17 degrees centigrade. The final temperature of the water is 100 degrees centigrade. Calculate the increase in the internal energy of the water. You see, the heat is equals to mc delta theta. So M is 2.5 kg, C is 4200 joules per kg per degree centigrade. Change in the temperature is 100 minus 17. When you do this calculation, you get 8.7 x per 5 joules. 8.7 x per 5 joules is the right answer, sir. I hope you understand this numerical. So we are going to the next question. That is question number 4. Red light of the frequency 4.7 x per 14 hertz travels in air at a speed of 3 x per 8 meter per second. A part is calculate the wavelength in air of this red light. Okay, you know that wave equation V is equals to F lambda, where the lambda is the wavelength. Okay, so V is equals to F lambda. Lambda is the question. So when you make lambda the subject of the formula will become lambda equals to V by F. So just substitute the values here. 3x per 8 divided by 4.7 x per 14. Just enter this thing in the calculator as it is. You will get 6.4 x per minus 7 meter. 6.4 x per minus 7 meter is the right answer, sir. This is the solution. And here we go. Question number 4, and it's B part. He says, figure 4.1 shows a narrow beam of this red light striking the surface of a parallel-sided glass block. So here the light, red light is entering into a glass block. Air is less dense. The glass block is more dense. This is the angle of incidence. This is the angle of refraction. He says, state what happens to the speed, to the frequency, and to the wavelength of the light as it enters the block. You see, when the light enters from a rare medium into the dense medium, the speed of the light decreases. What happens to the frequency? The frequency remains unchanged. And what happens with the wavelength? Whatever happens with the speed, the same thing happens with the wavelength. So the wavelength will also decrease. So these are my answers. So you can see the speed will decrease, the frequency unchanged, the wavelength decrease. Okay, you can look at the marking scheme as well. My answer. Okay. So question number 4 is B part, and I'm going to second portion. He says using the angles shown in the figure 4.1, calculate the refractive index of the glass. You know the formula for the refractive index is sine I is equal to, divided by the sine R, sorry. N is equals to sine I by sine R. So N will be equals to sine 45 divided by the sine 30. So N will be equals to, just enter these values in your calculator. Your calculator must be set in degrees. N is equals to sine 45 divided by the sine 30 equals to, and that will be 1.4. So the refractive index is 1.4. You can look at the marking scheme. Okay, this is my solution. Okay, question number, it is 4B and its third part. Using the angle shown on the figure 4.1, calculate the refractive. We are done with this. Okay, question number 4B is third part. The light continues along the path shown in the figure 4.1 until it strikes the bottom surface of the block. Light then emerges into the air. Draw on the figure 4.1 to show the path taken by the light until it strikes the bottom surface and the path of the light that emerges into the air. You see, when the light will emerge from a dense medium into a rare medium, its speed will increase. That's why it will bend away from the normal. And here you have to only show this. You don't have to do the calculations. Okay. So let me show you. So I think this diagram is showing up. You can see when the light will travel through the glass, when it will hit this surface, here the light will enter from glass into the air, from a dense medium into a rare medium, optically I mean, and optically denser and optically rare medium. So its speed will increase, so the light will bend away from the normal. You see, I have not followed the original path. I have changed it. It has bended away from the normal. And I hope you understand this. He says that it should be parallel to the initial. It's almost parallel to the initial one. Okay. So the next question is question number 5. He says most of the energy emitted by the sun is in the 3 regions of the electromagnetic spectrum. The name of one of these 3 regions is the ultraviolet. State the name of the all 3 regions in order of increasing the size. You remember that the formula for the code words, I mean, we use Ronald. We say Ronald McDonald is very ugly except Gary. So Ronald McDonald is very ugly except Gary. Here they have named the ultraviolet. Ultraviolet is this one. So the 3 main radiations which are coming from the sun, they are infrared, visible light, and so the smallest, as you go in this pattern, this is radio wave, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Ronald McDonald is very ugly except Gary. So the as you go down in this pattern, the frequency is increasing. So the smallest frequency is infrared, then you will have visible light, and then you will have ultraviolet. Okay, so let me show you. So question number 5A, first part, smaller frequency will be infrared, intermediate frequency will be the visible light, and the largest frequency will be ultraviolet. So I hope, I hope you understand this. I have shown you the marking scheme. Question number 5A and its second part. He says some of the ultraviolet radiation emitted by the sun reaches the surface of the earth. Give one possible damaging effect of the ultraviolet radiation on the human body and the property of the ultraviolet radiation that causes this damage. The UV light, the ultraviolet light, that causes skin cancer and that also causes cataract. That something develops on the eye and eye lens that is called cataract. And so the easiest word is skin cancer. You can talk about that. And why this happens? What is the property of the UV light that causes this? The UV light is ionizing, so it ionizes. So due to that, this happens. So the damaging effect is skin cancer, and the property UV is ionizing. So this is the marking scheme showing up. My answer, okay. He says the electromagnetic radiation is a transverse wave. This is the B part of the question number 5. Describe the difference between a transverse wave and a longitudinal wave. The difference between the transverse wave and a longitudinal wave. In the transverse wave, like water waves, the particles of the medium means through which the wave is traveling, the particles of the medium vibrate perpendicular to the direction of the wave. Whereas in the longitudinal wave, the particles of the medium vibrate parallel to the direction of the wave. Here is my written answer. In transverse wave, the particles of the medium vibrate perpendicular to the direction of the wave, while in longitudinal waves, particles of medium vibrate parallel to the direction of the wave. So here, my dear students, the marking scheme of question number 5B part is showing up. You can pause the video, take your time with this. This is my answer. And here we go to the next question. That is question number 6. Figure 6.3 shows a circuit that contains two identical cells, each of the EMF 1.5 volt, that are connected in parallel. You see, when you connect two 1.5 volt cells in parallel to each other, the total EMF of this system will be still how much? 1.5 volt. So the EMF of this battery is still 1.5 volt. The circuit also contains two ammeters, a transmitter T and two resistor, a thermistor T and two resistors R and S. R and S are fixed resistors. This is a thermistor whose resistance depends upon the temperature. And the reading on the ammeter 1 is 0.20 ampere. State why the reading on the ammeter 2 is also 0.20 ammeter. You see, in this circuit, you have connected all the things in series with each other. So the path for the charges or the path for the current is only one. So whatever that is, this is a rule that whatever amount of current comes out of the battery, same amount of the current goes back to the battery. Plus, there is only one path for the current. So whatever the reading will be showing up on the ammeter 1, same current will be showing up on the ammeter 2. Let me show you my written answer. Okay, R and S and T are connected in series with the cell, so the current has only one path. That's why the ammeter 2 and the ammeter number 1, they both will have the same reading. So this is my answer. Okay. Then he says the reading, okay, state why the reading on this one is done. The B part, the resistance R is 1.5 ohm and the resistance of the S is 3.5 ohm. Calculate the resistance of the T. The current coming from the battery, that can be calculated. The formula is very simple. Current from the battery is EMF divided by the total resistance of the circuit. The EMF divided by the R1 plus R2 plus R3. And so and the current from the battery is 0.20 and the EMF is 1.5 volt. The R resistance is 1.5 ohm. The S resistance is 3.5 ohm. And the thermistor resistance is question. So I will add these two. This will become 5 and 1.5 and divided by 5 plus T. So I will take this to here and this will come downstairs here. So when you divide 1.5 with the 0.20, you get 7.5. And this 5 will come here and subtract, and then you will have 2.5. So that resistance of the thermistor is 2.5 ohm. The resistance of the thermistor you can see is 2.5 ohm. I hope you understand this numerical. The current coming from the battery is equals to the EMF of the battery divided by the total resistance of the circuit. Then he says in the B second part, he says the temperature of the T increases. Explain why the potential difference across the T decreases. Okay. Now, when you will increase the temperature, the resistance of this thermistor will decrease. Okay. When the resistance of this thermistor will decrease, the equivalent resistance of this whole circuit will also decrease. So now a larger amount of current will come from this battery. The resistance of R and S is still constant. It's still the same. But now a larger amount of current is flowing through R and S. So here the voltage drop across the R and the voltage drop across the S will increase. Because the total voltage drop here must be 1.5 volts still. So if here the voltage drop will increase, the voltage drop across the T will automatically decrease. I hope you understand what I'm saying. So here we have my written answer. Let me show you. He says, when the temperature increases, the resistance of thermistor decreases. R equivalent of the whole circuit will decrease. Current from the battery will increase. Resistance of R and S is constant due to larger amount of the current through them. I mean, the voltage drop across the R and S will increase. So the voltage drop across T will decrease because the total voltage drop across these three resistors is supposed to be 1.5 volts still. Okay. So this is the answer I have written. I hope you can write a better answer. You can also look at this marking scheme. This is my answer. Okay, so we have question number 6, and the question number 6 is completed. Okay, now we are going to the next question. That is question number 7. He says, an alternating current AC generator is used in a remote location to supply electricity. Figure 7.1 shows the structure of a simple AC generator with the coil horizontal. So here you have an AC generator. State the name of the components labeled P and Q in the figure 7.1. So you see this P is carbon brush and this Q is slip ring. So here I have written my answers. So this P is basically carbon brush and this Q is called slip ring. Carbon brush and the slip ring. Hopefully you understand. It's very simple. He says when the generator is producing an electric output, P is stationary and the Q is rotating. Explain the purpose of P and Q, 2 marks question. You know this P, which is carbon brush, is stationary. So it's providing a connection between the rotating slip ring and the external circuit. The function of this Q is it is all the time connected to this coil. So it's providing a connection between the carbon brush and the wires coming from this coil, and it makes sure that it do not allow those wires to be twisted with each other, because that when this coil will rotate, this can happen. So the carbon brush provide connection between rotating slip ring and external circuit. Q, which is the slip ring, provide connection between coil and carbon brush, making sure the wires do not twist with each other. So this is that answer. This is my answer. So we are okay. So we are going to the question number 7. It's B part. He says the output of the generator is connected to an oscilloscope. On the oscilloscope, the Y gain is set at 5 volt per centimeter. You know, Y gain means the scale for the Y axis. Means on the Y axis, 1 square is representing 1 division, 1 centimeter is representing how much. So 1 centimeter on the Y axis is representing 5 volt. And the time-based setting is 2 millisecond per centimeter. That means the scale for the x-axis. On the x-axis, the time is represented, and its scale is that the 1 centimeter on the horizontal axis, x-axis, is representing 2 milliseconds. Their question is, write a letter X on the trace shown in the figure 7.2 to indicate one point where the coil is vertical. Whenever the coil becomes vertical, for a moment, the EMF produced in the generator becomes zero. Remember this fact. Whenever the coil in the AC generator becomes vertical, the EMF produced, induced in the generator becomes zero. So here, this point is basically, this point is also zero, showing EMF is zero here. On this point is EMF zero on this. So out of these 1, 2, 3, 4, 5, anywhere you can write X. For example, I have written the X here. Here the EMF produced is zero, so that's why it means the coil is in the vertical position. Using the figure 7.2, determine the maximum value of the EMF produced by the generator. Okay, so let me increase the size. So the maximum EMF induced, let me check how much is the amplitude. So from the mean position, it is going how much? 1, 2, 3, 3.6. So this has an amplitude of 3.6. So you will multiply 3.6 with the Y gain, which means 5 volt per centimeter. So 3.6 multiplied 5, that is 18. So it means the maximum EMF induced is 18 volt. So maximum EMF induced is 18 volt. This is the answer. This is my solution. Okay, then he says, now the question is, using the figure 7.2, determine in milliseconds the time it takes for one revolution of the coil. Okay, so we have to tell the time period. So let's say from here, if I start the wave, so here the wave is completed. So this is the time to complete one wave. So here 1, 2, 3, 4. There are 4 centimeter on the x-axis. 1 centimeter representing 2 milliseconds. Okay. So 4 will represent 4 multiplied 2, this much milliseconds. So 4 multiplied 2, that will be 8 milliseconds. That is the time period. And that answer is right. Okay, then their question is, they are asking you a question that determine the frequency of the output of the generator. If you want to frequency, if you know the time period, very easily you can find the frequency. The relationship between the frequency and the time period is that the frequency is equals to 1 by t, reciprocal of the time period, but the time period must be in seconds. Okay, so the frequency is equals to 1 by t, and the time period is 8 milliseconds, but I will convert this into the seconds. And how? By dividing it with the 1000. In 1 second there are 1000 milliseconds. So 1 divided by, here I have done that, 1 divided by 8 expo minus 3, and that is approximately 125 hertz. That is exactly 125 hertz, but when you round it off to two significant figures, then it will be 130 hertz. 130 hertz is the right answer, sir. I hope you understand. So we are going to the next question. The question number is question 8. Uranium-235 is the isotope of uranium that is used as the fuel in the nuclear power station. The isotope of uranium that is most abundant in nature is uranium-238. State how a neutral atom of uranium-235 differs from a neutral atom of 238. You see, they are the isotopes of each other. So in their nucleus, they have the same number of protons, but the difference is between the number of the neutrons. So in here, from 238 subtract 92, here 235 from 235 subtract 92. That will give you the number of neutrons. So here is my written answer. In uranium 238, there are 146 neutrons in the nucleus, while in uranium 235, there are 143 neutrons in the nucleus. And I hope you understand this is their answer. So this is my answer. I hope you understand. Okay. Question number 8 is B part. He says in the reactor of a nuclear power station, a nucleus of uranium-235 absorbs a slow-moving neutron and undergoes fission. State what happens in the nucleus to the nucleus of an atom during the fission. In the fission process, a larger nucleus, when bombarded with a neutron, it splits, it breaks into smaller nuclei. So, and this is during the fission, nucleus bombarded with neutrons splits, breaks into smaller nuclei. During this, more neutrons are also given out. Okay, so question number 8B, second part, he says, explain how fission can lead to a chain reaction in a reactor. You see, we have one uranium-2 nucleus. You bombard it with a neutron. It splits into barium and krypton, and three more neutrons are released during that split. So those three neutrons will do the fission of three more uranium atoms. And from those three uranium atoms, when they will split, they will give out total 9 neutrons. And those 9 neutrons will do the fission of 27. And 27, when they will give out three neutrons, they will start the fission of 81 uranium. So you see this process, once you have started it, this goes on because of the production of the neutrons during the fission and of the uranium, and so this starts chain reaction. I hope you understand. When the fission of the first uranium-235 takes place, it splits into two smaller nuclei and three neutrons are released. These three neutrons are used to do fission of three more uranium-235 atoms. From them, when they do the fission, from them 9 neutrons are released and they continue doing fission in this manner. So this starts a chain reaction. I hope you understand. Question number 8B part. And so see, you can read, you can take time with this marking scheme. It's a 4 marks. Question check. What mark? 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this. I hope you will be able to write a better answer. You can also consult your latest books. Okay, then he says, state the purpose of the moderator in a reactor. The purpose of the moderator in a reactor is slow down the neutrons, because when the neutrons are slowed down, their probability of doing the fission of a uranium atom increases. Moderator slows down the neutrons produced during fission. Slower neutrons have higher probability of splitting uranium-235 or doing the fission of the uranium. So this is the answer. Okay, this is my answer. Okay. And the fourth part is explain the action of the control rods in the reactor. The function of the control rods is to absorb the neutrons. So they can absorb the neutrons. When they will absorb the neutrons, the process of those neutrons cannot do fission of the uranium 235. So by the control rods, I am able to control this fission reaction. I can completely stop this fission reaction with the help of the control rods, or I can slow it down. I can control the fission reaction. Control rods can absorb neutrons and can control fission reaction. By stopping neutrons, fission reaction can be slowed, or it can be controlled, you can say. They absorb the neutrons, and so you can look at this marking scheme, you can look at this answer and then write your own answer. You can consult your book also. Okay, so we are going to the next question. That is question number 9. He says the planet Venus orbits the sun at a constant speed of 3.5 x/4 meter per second and takes a time TV to complete one orbit. A part is Venus is always 1.1 expo 11 meter from the sun. This is the radius of its orbit. Calculate the the time period for one. Okay, so you know the orbital speed is 2 pi r divided by t. The speed is 3.5 x per 4, 2 pi. The radius of that orbit is 1.1 x per 11 meter, and the time is question. So the t will be equal to 2 pi multiply 1.1 x per 11 divided by 3.5 x per 4, and you will get 1.97 x per 7, which is approximately 2 x per 7 seconds. 2 x per 7 seconds is my answer, sir. This is my solution. Okay, the question number 9, its B part is explain why speed is a scalar quantity. Speed is a scalar quantity because it has no direction, it has only magnitude. That's why we call that speed is a scalar quantity. Speed has only magnitude, it does not have direction. Okay, so the next question is C part, question number 9, C part. He says, velocity is a vector quantity. Explain what happens to the velocity of the Venus as it orbits the sun. You know, because that orbit is circular, so as the Venus moves in that orbit, it's moving in a circular orbit. So the direction of that velocity all the time is changing. Velocity of the Venus changes as it orbits the sun. Orbit is circular, so the direction of the velocity changes. Magnitude of the velocity is although constant. He said the speed is constant, but its direction changes. I hope you can see this marking scheme. This is my answer. So, C and second part, there is a resultant force on Venus as it orbits the sun. The force is perpendicular to the direction of the motion of the Venus. State why this force is needed. You see, when you move in a orbit, in a circular orbit, you need to change the direction of your motion, direction of the velocity. For that, we need a resultant force. We need a force. This force is needed to change the direction of velocity and it keeps the Venus in circular orbit. This force provides the centripetal force and it produces acceleration. This is my answer. This is the answer. Okay, then we say the figure 9.1 shows the orbit of Venus around the sun. On the figure 9.1, draw an arrow to show the resultant force on the Venus. The resultant force is always toward the center of that circle. So we will draw an arrow which will be towards the center of that circle. Then he says, state what causes the force acting on the Venus. This centripetal force, this force which is towards the center of the sun, towards the sun. And that force is due to the gravitational attraction between the sun and the Venus. Gravitational attraction between sun and the Venus provide this force of traction, and the Venus is inside the gravitational field of the sun. You can see this answer. You can okay. Now, then he says one planet in the solar system is closer to the sun than Venus. State the name of this planet. Okay, so how you remember the order of the planets around the sun. We say my very educated mother just served us nachos. My very educated mother just served us nachos. This means Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So the Mercury is closer to the sun as compared to the Venus. So you will write here Mercury. Then their question is compare the time that this planet takes to complete one orbit of the sun with the t of the time period of the Venus around the orbit and explain the difference. You see the orbit of the Mercury is smaller as compared to the orbit of the circumference of the orbit of the Venus, plus the orbital speed of the Mercury, the planet Mercury is larger as compared to the orbital speed of the Venus. So that's why the time period taken by the Mercury to do complete one orbit around the sun is less than the time taken by the Venus to complete one revolution, one orbit around the sun. So circumference of the orbit of the Mercury around the sun is relatively smaller than the orbit of the Venus. Orbital speed of Mercury is larger than the orbital speed of the Venus. So the Mercury takes less time to complete its orbit around the sun. He says time taken is less and orbital speed is greater, circumference of the orbit is less. Circumference of the orbit is less and orbital speed is greater. Yeah, this is the reason which I have also written. So, my dear students, we have reached the end of this paper. So, my dear students, today we have done October, November 2023 2-1 paper. And in this single video, we have done the whole of the paper. So you will find all, there are no A part, B part. Previously, there were A part, A section, and B section in the paper. So the whole of the solution of this paper is in this video. I have tried my best to explain you the concepts and write the answers to best of my knowledge. I'm a human being. I can make mistakes. That's why we all the time are using the marking scheme as well. It's a very important habit to always check your answers, your teacher's answer, compare them with the marking scheme. If you find this video interesting, it's useful, you hope that this can help you, it can help your junior students, it can help your class fellows. Please share the link of this video onto your Facebook, onto your WhatsApp, onto your Twitter, onto your Instagram, onto your X. When you do this, this helps me to promote my channel. I think it's a great blessing for me that I can make these videos which can reach the students around the globe. Thank you very much for watching these videos. Please like this video also. Have a good day. God bless you all.